Welcome to Chapter 2. Quick reframe from Chapter 1. Last chapter was about how the browser and server talk to each other, and you deployed a bare-bones HTML file, doc type, head, body, one heading. That was intentionally simple. Today we start adding real structure. 2 skills this chapter: planning a page visually with a wireframe before writing any code, and turning that plan into HTML that actually means something, using semantic HTML tags that describe what content is, not just how it looks. By the end, you'll have a wireframe of your own homepage and a semantic rebuild of it, even though it won't look styled yet. That's Chapter 3's job. These are your 5 targets for the chapter. Notice the verbs: create, explain, use, choose, restructure. That last one, restructure, is the giveaway that this chapter builds on something you already have. You're not starting from scratch. You're going back to the Chapter 1 page and rebuilding it properly. Point out the 7 semantic elements listed here by name, since that exact list is the vocabulary test later. Header, nav, main, article, section, aside, footer. Connect this directly back to Chapter 1's sitemap. A sitemap is a tree diagram. It answers what pages exist and how do they link together. It says nothing about what's inside any one page. A wireframe answers a completely different, narrower question. What does one page look like? Use the blueprint analogy from the textbook if it helps. Sitemap is the blueprint for the whole building. Wireframe is the floor plan for one room. Same underlying principle as Chapter 1. Plan before you build, just applied one level deeper. Emphasize what a wireframe deliberately leaves out. No colors, no fonts, no real images, no finished copy, just labeled boxes. That's not a limitation, it's the point. A wireframe answers exactly one question: where does each piece of content go? Anything about color, font, or exact sizing is a CSS question, and CSS is Chapter 3. If a student starts describing colors on their wireframe, redirect them. That's next chapter's decision, not today's. This is the target shape students will build in draw.io. Header, navigation, main content, sidebar, footer. Point out the 4 required regions for their own assignment: header, navigation, main, and footer. Sidebar is optional. Not every page needs one. This slide is the direct preview of Assignment 1. 3 concrete costs of skipping this step, worth saying out loud. Moving a box in a wireframe tool takes seconds. Finding the same layout problem after you've written, styled, and filled in real content costs far more, because now you're restructuring actual code, not dragging a rectangle. Also flag the real-world pattern from the textbook. A page built with no plan turns into a tangle of generic containers, with things wedged in wherever they fit, and every new feature after that gets more painful to add. Professional developers plan first almost without exception, not because they can't skip it, but because skipping it costs more later than it saves now. This is the conceptual heart of the chapter, so slow down here. Semantic means meaningful. A semantic tag describes what its content actually is, not just how it should display. Contrast the 2 examples on the slide. A generic, short for division, just a generic content container, tells the browser nothing. It could be a nav menu, a footer, an ad, anything. A tag announces something specific. This is navigation, and that announcement isn't just cosmetic. It's read by screen readers, software that reads a page aloud for visually impaired users, by search engines trying to index the page, and by other developers, including a future version of you, trying to read the code later. Land the keyline. Semantic tags are your wireframe's regions, turned into actual code. This slide is a side-by-side comparison. Walk it left to right rather than reading it top to bottom. Left side, the old way. Everything built with generic less than divid equals greater than containers. Right side, the modern semantic version. Point out that the browser renders row looks visually identical between the 2. Same boxes, same layout. That's the whole point. Semantic tags don't change what the page looks like. What changes is the result row underneath. The div version has no meaning, is harder for search engines, and is worse for accessibility. The semantic version is clear, better for SEO, better for screen readers, and easier to maintain. If a new acronym comes up here, ARIA, Accessible Rich Internet Applications, you can mention semantic HTML needs less of it, but it's not something they. This is a visual walkthrough of a real HTML document. Trace it top to bottom. Holds introductory content, logo, site title, tagline. Holds the navigation links. Is the primary content of the page, and there should be exactly 1 per page, not 0, not several. Walk through the actual code on the right, so students see these tags aren't abstract. They're literally what's inside a real index, HTML file, including the boilerplate above the body, doc type, meta charset for character encoding, and the viewport meta tag that makes a page behave on mobile. This builds directly on the previous slide by adding the 4 remaining tags, connected by arrows. New in this shot, a thematic grouping of related content that's tied to the page it's on. Like a chapter in a book, it doesn't stand alone. A self-contained piece of content that could be pulled out and published elsewhere and still make full sense. A blog post, a news story. Related but separate content, like a sidebar or pull quote. Not every page needs one. And the closing content at the bottom, copyright, contact links. Notice in the code that and are nested one level inside, while header, nav, main, and footer sit as direct children of Joule. That nesting is worth pointing at explicitly. It's easy to get wrong. This is the slide students get stuck on most, so give it real time. Both and group content, but the difference is independence. Ask the class the 2 test questions directly. Is this just one themed chunk of a bigger page? That's. Could this be pulled out and published on its own and still make sense? That's. Walk both code examples. The blog post page uses for introduction, principles, tools, and resources. None of those make sense ripped out of that page. The article listing page uses for each individual post. Each one is a complete, standalone piece of writing. Point out you can nest both. A. Introducing a blog, containing several elements inside it, one per post. Address the obvious question directly. If semantic tags don't change how the page looks, why not just keep using for everything? Answer. Still has a legitimate job. Pure visual grouping where no semantic meaning applies, just a box to style. But for the structural backbone of a page, semantic tags give 3 concrete benefits alone. Can't. Accessibility. Screen readers can jump straight to a named region instead of announcing an undifferentiated string of generic containers. SEO, which stands for Search Engine Optimization. Search engines understand and index the page better. And readability/maintenance. Another developer, or future you, can scan the structure instantly. Use the vivid example from the textbook if there's time. A screen reader moving through an all div. This is the full semantic skeleton. The shape almost every page in this course will follow from here forward. Point out the nesting explicitly. Less than header greater than, less than nav greater than, less than main greater than, and less than footer greater than are siblings, all sitting at the same level directly inside less than body greater than. Inside less than main greater than, the actual content, wrapped in less than article greater than, less than section greater than, or both, sits one level deeper, with less than aside greater than alongside it if the page needs a sidebar. Getting this nesting right isn't a style preference, it's what makes the structure of the page actually correct. This is the pattern students will be rebuilding their own homepage into for assignment 2. This diagram is the direct mapping exercise. Wireframe region on the left, semantic tag on the right, connected one-to-one. Header box becomes less than header greater than, nav strip becomes less than nav greater than, main content area becomes less than main greater than, sidebar, if present, becomes less than aside greater than, footer bar becomes less than footer greater than. Say the framing line on the slide out loud. Your wireframe shows how it looks. Semantic tags show what it is. If a student is unsure which tag a wireframe region should become, that's usually a sign the wireframe's label itself wasn't clear. Send them back to fix the plan, not the code. Set expectations before students build their own page, because this trips people up every semester. With no CSS yet, their semantically structured page is going to render as a plain vertical stack. Header, then nav, then main, then footer, straight down the page, with zero visual resemblance to their wireframe's layout. That is expected. It is not a mistake. Semantic tags carry meaning and structure, not appearance. Same as a labeled blueprint not looking like the finished building. Today's job was correct structure. Next chapter's job, using CSS, is correct appearance. Same HTML, same content, only the CSS changes. Compare the 2 code panels on the slide side by side to drive that home. This is the full chapter recap graphic. Use it to pull everything together, rather than introducing anything new. Left half is visual planning with wireframes. Focus on layout, not style, catch problems early, and the 4 essential core regions. Right half is coding with meaning. Ditch generic div tags, ship semantic tags instead, and the triple threat benefit SEO, accessibility, and maintenance. The old way versus modern way table at bottom right is a good one to linger on, since it condenses slide 8's comparison into one glance. This week's 2 assignments, plus the quiz. Assignment 1. Wireframe your own homepage, built in draw.io, submitted directly in Canvas. Assignment 2. Rebuild that same page with real semantic tags, header, nav, main, article, aside, footer, updating their public index. HTML from Chapter 1. Make sure students understand Assignment 2 builds on Assignment 1's plan, not on a fresh idea. The wireframe they draw this week is the one they'll be coding next. The quiz checks their grasp of wireframes, semantic HTML, and the 7 core tags.